All right, we're going to do things a little bit different than what some of the past guys have done. This is electrical hazard awareness for first responders, and I've been doing this for about the last 2 years. SMI, Safety Management International, ISPC, and T&D PowerSkills, we're all one big happy family. We work together trying to create the best product, and I guess we do have the best product out there for apprenticeship training through the T&D PowerSkills. You'll meet Jerry next month, and he'll be here representing that. You've already met Jim Vaughn and Dan Taylor and Mark Forster, who's going to be an ISPC employee this month, I believe. So what I have been doing for the last couple of years, I've gone through all the FEMA supervisory classes and things, finding out what emergency management is all about. And one of the things that we've realized is there is a lack of safety, especially on the electrical side, for our first responders. The firefighters, ambulance drivers, and police. And then a lot of emergency events that happen. They get volunteers to come out. Like, for instance, if there's a tornado, they'll get volunteers to come out and try to help anybody that needs help. And they have no electrical training, don't realize what the hazards are. So I'm going to start off with a challenge. And as utility safety professionals, we really have a responsibility to help these first responders. So wherever you are, there's first responders in your area. I worked with the electric utility several years ago, and I did a lot of this, just coming to fire stations and letting them know what the electric system is all about. One of the biggest responses I get to the question, have you ever unplugged a meter at a house, to our firefighters? And the answer I always get is no. Well, I actually worked with the electric utility for 20 years, and I've had to respond to several house fires. I never got to one house fire that the meter was not already laying on the ground. So we know that they're doing this, and they get away with it, so they just keep doing it. The picture that you might see on the screen, we have a firefighter. This was actually in Westlake, which is right outside of Lake Charles, Louisiana. A couple years ago, we had Hurricane Laurel that came through. And if you can see, he's walking down the street with bolt cutters in his hand. And I totally understand. First responders, they're trained to provide help and assistance. And they need to do whatever they need to do to get to these folks that need help. And sometimes cutting power lines down and moving them out of the way is one method of getting to the folks that need it. But there's a lot more hazards now than there was 20 years ago. This is 6 reasons that first responders are at an electrical risk. They work, first off, in a high-risk environment. The awareness that they have is, how can I get to this person? And everything is new every time. There's never a typical house fire. There's never a typical medical emergency. Everything is a little bit different everywhere they go. So it starts off as a high-risk environment, and they don't have any electrical awareness training. So if power lines are down, they don't think a thing about moving them out of the way. We have so many ways of backfeed nowadays to backfeed lines that are actually laying on the ground. I've got a couple of videos that I'll show. They're not really aware that electricity is everywhere, in a house. I've actually done a few interviews with several firefighters that have gotten shocked. We don't kill a whole lot of them, Although I think we had 6 that died in 2022 from electrical shock, and that was just firefighters. I haven't looked at any ambulance drivers or police, but you know, they kind of know that electricity is everywhere, but how do they, and you know, they're walking into a house with a hose spraying water. And so the lack of awareness for our first responders, doing electrical education, that's what I'm trying to do here. For all of our safety professionals that are out there, I have a presentation put together, and I'll go through some of it here. But if you want, I can certainly send you this presentation. I've given it to a few police forces. They've gone through to their firefighters. And you know, the big thing is they need to know what the hazards are so that they can stay safe. Firefighters, police, they don't get electrical PPE. They don't have rubber gloves. You know, they have rubber boots for the most part, but they don't understand that those are not insulated boots. And I have a picture of that coming up. And then their solutions for, you know, fighting the electric side of things is very limited. They don't, you know, have the knowledge that they need. I submit that we share with them how electricity flows, how it's measured, the various voltage levels. And like I said, I have the presentation, you know, everything from transmission to 120 volt inside of a house, electrical hazards. We're going to go through that. I tell them how electricity is always trying to get to earth. It takes every available path to ground. It moves at the speed of light, so it's not like you can touch it and then remove your hand before you get shocked. It travels too fast. So just some of the hazards we go through. Here's an interesting picture. This was taken in Florida after Hurricane Nicole. So you can see trees are down, power lines are down, kids are walking on wet sidewalks right next to down power lines. We actually had 2 people killed in Florida from a down power line. It was a backfeed through a house generator. They didn't suffer any damage at their house during the hurricane, but they had some kids that lived a couple miles away, and because communication was out, they wanted to go and check the kids, see how their house was doing. It was a little bit closer to the water. So they got in a vehicle and started driving. Well, there's some power lines down in the road. The man got out, grabbed a stick, and of course the stick was wet. He went to move the power line and it killed him. So the lady that was in the car, she went out to try to rescue him. He was still in contact with the power line. She touched him and she was killed as well. So we do have those hazards out there. We've always told all of our first responders, we tell everybody, if there's a down power line, if there's a down telephone line, it doesn't matter, do not touch it. But we do know that they are going to do something to try to move that line out of the way so that they can go save lives. I have a couple more instances that we'll talk about. Here we have a fireman's boot. He was actually, the line was down. It was a 120 volt line, and he stepped on it and it actually shocked him through the boot. Why? He was wet. Everything was wet. Now, it didn't kill him, but you know, it did leave a nice little mark on his boot. So even at very low voltage levels, there's the hazard. Hazard levels from electric current is measured in milliamps, and even a lot of our line workers don't realize how much amperage is actually flowing on grounded lines. Jim Vaughn was here and he talked a lot about grounded lines, and so we're learning a whole lot more than we knew, and we're learning a whole lot more than we knew in the past about how amperage flows on grounded lines. You know, all you need to do is get in 2 different potentials and it's enough to kill you. It doesn't take a whole lot. 1 milliamp is equal to 0.001 amps, which is not very much at all. The lowest level of current that becomes a hazard to workers begins at 50 milliamps. So that's 0.05 amps. Now, to compare that, it takes 50 volts to break the electric resistance of your skin. If the voltage can break the skin, the current can flow, and that can kill you. We have lots of hazards even inside of our homes, and you know, the electric outlets that are in your homes. Has anybody ever had a kid that tried to stick a knife or something metal in one of those? That's why we had the little plastic things to keep them from doing that. So Charles Daziel found that the skin resistance on humans are anywhere between 20 and 100 volts. So if you have a lot of calluses on your hand, big tough worker, you know, it may take almost 100 volts to actually break the resistance of your skin. But people like me and little kids that have tender skin, it may only take about 30 or 40 volts to actually penetrate our skin. And then it doesn't take a whole lot of amperage to go through us. Here we have a picture of a line that's on the ground. It's still energized. It's actually catching the grass on fire. So one of my questions when I go out to train firefighters is, would you spray water on this fire? And they don't know any better. So you got a guy that's wet usually already, and then he's going to walk up to this with a hose. There's still electricity flowing through this line. And if he goes to spray water, and I've talked to a few of them, they said, yeah, I have received an electric shock, you know, just spraying the water like that. So here you would need some kind of chemical to put the fire out. Or the best thing to do is keep everybody away, keep them clear until the utility company comes and they can de-energize the line. I've had that several times through my career. Not only is the, you know, touching the electric line a hazard, we also have the electric arc. So one of the things that I talk about, and I have a little story to go with it about meters, is you know, the guys are pulling the meters. A lot of times if the house is on fire, we already have short circuits that are inside. If the breaker hasn't tripped, they may get a flash when they try to pull that meter out if it's a phase-to-phase fault in there. So you know, just pulling a 120 volt meter out of a house can cause an electric arc that could do some damage. House meter fires. I read an article not too long ago that was very negative about our new ERT meters, is what we call them, the smart meters that send a signal back to the utility. The article was really down in these because they were catching fire, and you know, it was a myth, I guess, that the meter itself was what was catching fire. Faulty installation is, once they did some investigations, is what they found out was actually causing the fires. So this was up in the northern part of the United States, and I am here to just say that smart meters do not cause fires. All right, so if somebody's watching this and you know, you have a smart meter on the side of your house, it's not likely going to catch fire. So you know, there's been some things like some shorts and things like that that have actually you know, set the meter on fire. The training that I do with the firefighters on this event is, do you want to go up and spray water on a meter that's on fire? A lot of firefighters have started purchasing fire blankets, which actually smothers out the fire. So here I have a video that has a line coming down, and what's interesting is the comment. I think we have a couple of young fellows that are in this Taco Bell that are, you know, videoing it on their cell phone, and I want to talk about what they hear.
Yeah, that's live wire. There goes the transformer, Blue.
There goes electricity.
I say somebody call MLG&W.
Somebody calls, yeah, 911.
911.
That thing's live, isn't it? Look how live it is.
It is live.
So glad somebody wasn't walking out there, man.
Or driving.
No, they'd have been fine with the tire.
Yeah, but a lot of people don't know that. They think that they try to jump out.
That's a lot of electricity right there.
Yeah, it is.
And that's more than 115 volts too.
Is that bird gonna survive?
The bird? Depends on if it crosses lines.
Guarantee that was the wind snapping, making those lines.
Yeah, I saw it fall from. It came loose from that pole there and it split.
Dang.
Oh, it did.
Finally, it blew.
Fire blew up. He gone. Ain't gonna be no more smokes. There he gone.
Now this video has been out for a while, so probably a lot of people have seen it. I just like the comment that the kids are making. There's the transformer blew. Well, I think what we have here is, it looks to me, the video is not real good, but it looks to me like the static wire on top has fallen, burnt into somewhere, fallen, and then we have 3 transformers that are on the pole. So we have the taps that are actually feeding those transformers. So as the wind is blowing, it actually energizes the line and starts setting grass on fire. You can see the arcing. It's not creating enough fault current to actually make a breaker trip until right at the end where you saw it looked like it went phase to phase, and finally the breaker trip. I don't know if you still see the video, but you can see the bucket truck coming in. Now, what should these guys have done? I mean, they're shooting it with their phone. Could we go outside and make sure nobody is around this thing? You know, be aware of a down power line. Let's not let anyone go near it, or you know, let's secure the area until the bucket truck comes and they can use a Bierer meter to make sure that the lines are de-energized. So you know, keeping the area clear. Years ago, I had a firefighter that was very close to getting injured. A wire went down. I was working for the utility. I got the call. It was like 2 o'clock in the afternoon. Wire went down, and it was actually laying across some trees, but at the end, it was on a fence. And it was a single phase line. They had a recloser that was feeding it. So it created enough fault current that the recloser opened, and about 5 seconds later, the recloser closed back in. And the way that it was laying on the trees, it was just kind of, you know, burning up some of the bushes. The people, when I got there, the fire department was already there, and they were in the street, kind of, you know, keeping everybody back. The folks inside the house came out on their porch, and the metal fence went almost to that porch. And one of the young folks on the porch was about to go out toward the fence. And I had to holler at him to stop, because I had to drive back and actually open up the recloser and then come back and test the line to make sure everything was down. I had a bucket truck that was on the way to help pick the wire up. But you know, they were staying clear of the down power line, but it was in contact with a fence. And when it re-energized, it actually arced on the fence. So I was able to keep them away. But I just remember the reaction of the firefighters while they were there. You know, it's like, oh, wow. I guess if I'd have touched that fence, it would have shocked me. I said, yeah, it probably would have killed you. And so, you know, they just don't have that electrical awareness. So in the training, I try to teach them what cutouts look like, what a cutout does when it blows. We also do some training for telecommunication workers who work on the poles right underneath the electric lines. And if there's transformers on the pole or a tap going off the pole, there's going to be a cutout up there. You can see the center picture where it makes quite an explosion coming out. So they are at risk somewhat. I just try to let them know that even if the cutout is blown and the cutout door is hanging down, it does not mean that that line is now de-energized. The only way to know that it's de-energized is use a Bierer meter and get it tested. So there are times where there may be an event of trees on the line, things like that, hit the line, and it's still in contact above the cutout. So it still might be energized. We just look at the cutouts and see, are they closed in, are they out, what is connected to them. Some other hazards that a lot of folks don't think about, underground hazards. If there's a house on fire or whatever, and some of our first responders may get up to a pad mount transformer. I want them to know that these are full of ants for the most part. Ants love transformers because of the heat. Black widow spiders are usually always found, especially in the south, in here. The picture on the right is from OG&E. OG&E sent us this years ago, and they opened up the box and it's full of snakes. Yeah, that's the reaction everybody gets when I show them this picture. The number 6 copper pole bond. Everything connected to the pole bond is grounded and bonded. So a ground wire that's coming down the pole, you have the system neutral is bonded to it. The telephone communication, all the cables up, they usually bond to that because we need a good ground to operate our equipment. What a lot of people don't realize, they should now that Jim has been here teaching some of the grounding platforms, there's always amperage on these grounds. Now, is it a hazard? No. It's perfectly safe. Everything's bonded and grounded. But if I was holding this ground wire and a truck down the road hit a guy wire and made the conductors, the energized conductors, touch that neutral, it's going to energize this too. Now, how many volts, we don't know. Every scenario is a little bit different. But, the point is we don't want to spend a whole lot of time in contact with things like this. Is it perfectly okay for the public? Yes, it is. I mean, if it was a hazard and we had people in the public that was walking by touching and getting shocked, the electric utility would do something about that. So it's perfectly safe unless there's an event. And, when those events happen, we never know. One of the things that I try to inform our first responders is personal voltage detective devices. So they actually detect in the proximity of energized conductors. There's one that would fit on your hard hat. We have one that they would wear around their neck. There's one that you can wear as a wristwatch. We don't promote any one of these products, but getting them to use them is the problem. We've had police departments that have bought several of these. We've had fire departments that have bought several different ones that I've talked to. And they get to a house fire, they get to a vehicle collision where wires might be on the ground, getting them to take it and actually put it on and turn it on to let them know if there's an energized conductor there has been difficult. So there is methods and equipment that we can use. Getting them to use it is, pretty much a struggle. So some overhead and underground system hazards, energized lines and equipment. You can see where this pole has fallen on a forklift. So if you're the forklift driver, first off, you were lucky and you had a good headache rack. But getting off, if the forklift is actually in contact with energized conductors, then, if you stepped off of the forklift, you can see that the ground around it is very wet, and you would very much be at a different potential. So drop and roll from our, if you're on fire, we always tell people drop and roll. But if you're on this, you want to not step, but jump off of it and then shuffle your feet until you get away, because we might still have a potential ground grid. All right. Tension on our poles. The conductors, the guy wires are all holding back tension. So if there's a collision and a pole has gone over, just because it's laying on the vehicle or just because it's laying on the ground doesn't mean that the hazards have gone. There's still tension that may be holding a pole up if it didn't go all the way to the ground. That wire or guy or whatever might break and cause more of a hazard. I want to talk about this for a little bit because in 2002 we had a truck and a car had a collision, hit the pole. The pole went over, but the way that the wires were, it didn't hit the ground. The recloser tripped, and about 15 seconds later it actually came back on. So the wires were laying on the ground. The lowest wire was about 4 feet off the ground, and the passenger in the car was injured. So the first responders came, they got the driver out, and they were okay, but the passenger needed a gurney to get them out. The police were there, everyone was standing around, fire responders and our ambulance folks all showed up. And the guy, kind of got on his hands and knees, got over to the passenger side, opened the door, was administering some care to the passenger. And I think she needed a neck brace or whatever. So he had the gurney that was right there, and the other guy came in, tried to straighten the gurney, got her out of the seat on the gurney and backed right into the power line, and it touched the back of his neck and killed him and her both. The other ambulance driver received a little bit of a shock, but he didn't die. So, the wires were down, they weren't touching the ground. The recloser re-energized them, but no one was aware that those wires were energized, that, don't touch down power lines. Well, we're going to do what we have to do to try to rescue somebody. 1974, there was 4 that died. This was up north, same kind of traffic collision. These wires actually went down into a ditch that maybe had about 2 or 3 inches of water in it. The victim was actually in the water, and the power lines were in the ditch but not in contact with the water. So anyway, this story was just so weird. 4 people had to try to restrain this guy to get him up out of the ditch, and while they did, the wind blew, from a report, the wind blew and killed all 4 of them and the victim. So, or killed 3 of them and the victim. So 4 died. Yes, that was way back in '97, but these things are happening, not all the time, but they're still happening. They're happening enough that we need to be aware of the hazard. Chemical hazards. Oil hazards, battery acid, lithium-ion batteries in our new EV vehicles. Now, are they more dangerous than our gasoline engines? And I'll have to say no. The problem is they're all catching on fire. Hurricanes in Florida, one of the things we found out about these electric vehicles is they don't like salt water. As much as 2 weeks after the hurricane has come through, electric vehicles that are parked in garages, the battery has just ignited and burned the houses. We actually had a firefighter that was injured after one of those. He didn't get electrocuted, but they actually got the fire out on the car, and it was parked in a garage underneath. and he went up into the attic and was making sure that there was no embers left that was going to catch fire. And the car ignited again. When it ignited again, the flames come up around him. He missed one of the boards that he was supposed to be walking on, and actually came through, landed on the car. And so he didn't, he had a few minor injuries, but still, these things, we have to know what we're doing. Like I said earlier, a lot of our fire departments have gotten blankets, and that's the best way to put these things out. They, have huge blankets and about as big as these banners, and they just go over the car and cuts the oxygen to the car and puts the fire out. Trees in contact with power lines. One of the things that a lot of people really don't understand, a tree and a piece of wood or a 2x4 is not an insulator. Trees have sap. Boards that lay on the ground may get wet or damp, and they become a very good conductor. So I have a video. Here we have a couple of pictures of trees on the line. The lines hold up pretty good, but not always. There was a young man killed, it's been about 10 years ago now. He had a personal voltage device that he was wearing. It told him that all the lines were energized. A very small tree that was just outside of the right-of-way was laying on the line, and he thought he could just grab the tree and pull it off the line. So he walked up to it. It was just a very small tree, and he went over and went to push it off the line, and made contact, and it killed him. 22 years old, just had a baby, So trees in contact with power lines. Here's another video. I like to hear the guys' reaction. This is another couple kids that actually took this on their phone, or young men.
That's the electricity running up the flames. That's cool. I'm doing video, yes sir.
That's why we don't get near it. That's why we don't get near it.
May I assume the power's out now?
No, you may not.
The power is out now.
I know you still got one leg up there.
Yeah, but it's probably kicked the breaker now down there. It's dead in line.
You can hear the statements. Power's out now. Oh, it may be, So yeah, it probably is. We don't know that. The trees we see are conductive. One of the questions when I'm training is I ask, the tree landed on the line. If you're a customer and a tree lands on the line, your lights go out. The utility has to come and put the power back on for you. But here, this tree was on the line and it burned for quite some time before it burned a line down is what happened. And that probably tripped the recloser, created enough fault current that a circuit breaker had tripped. So it's likely that it's not going to come back on, but it is also probable or possible that it could come back on and burn again. So we don't know where the line is. There might be lines adjacent to it or whatever. So I try to use this for our firefighters, our first responders. Even if a tree has burned the lines down, it is still not safe to go near it. All right, let's wait for the electric utility to come and take care of it. check the voltage and make sure it's de-energized before you can do any response. All right, I mentioned circuit breakers. The circuit breaker that's in your house works, basically the same as on the distribution system. We have a fault and the breaker trips. The difference is at your house, if your breaker trips, first off, you want to know what caused it to trip, but you have to go to your panel and actually, physically turn it back on. The utility system substation circuit breakers work just like that. However, downline and in a lot of our substations, we have what we call reclosers. And the reclosers are set to coordinate with fuses downline and things like that. So it depends on where the fault is. But just because something, a tree on the line, car hits a pole or whatever, we may lose voltage briefly. So every utility system is a little bit different. Some have 5 seconds, some have 15 seconds. I know one co-op that has almost a minute before it comes back on. So in that minute, when you see that the lights are out, you assume that they're not going to come back on. So after a while, it may be that the line may come back on. So never take for granted that a line is totally de-energized. All right, another hazard that our first responders face now is solar. I've gotten a lot of kickback on this. Net metering, okay? A lot of customers have purchased enough solar power that they can actually sell power back onto the grid. Now, if it's hooked up properly, if the grid goes down, there's a switch that should open, and I say should open. They get tested and, they should operate. However, we are relying on a switch. So no one actually physically goes to the switch to verify that it is open. So there is a possibility that they could backfeed to the grid. Now, would they be creating enough current to, make the line actually, set grass on fire or arc on the ground? And the answer is probably not. But it is still, like I said earlier, half a milliamp might be flowing through it, and that's all it takes, 50 volts to penetrate your skin. And, so now, down power lines does not mean that they're de-energized. Another problem that's been happening is solar fires. The way that solar panels, and I've tried to do a little study on this, but the way that the solar panels are set, if they're not operating correctly, they're almost like, have you ever taken a magnifying glass and burn ants? All right, so if they're not working properly, they can work like that, and that's what would cause a solar fire. Now, I don't want to get anybody panicked that, hey, I got solar panels on my house, it's going to catch fire. No. It does happen, but it's not very frequent that it does happen. Equipment failure, I put this in because it was so tragic. I assisted in the accident investigation on this. The line worker that was killed in this bucket, his wife worked at the school. He went and did electrical awareness demonstrations at schools. She was a third grade teacher. We had the entire third grade out there, almost 200 kids. They were standing out in the field, and he was scheduled to do a demonstration about 9 o'clock that morning. When he got to the office that morning, he had some mechanical trouble with his truck, and he was one of these guys that always inspected his truck every morning, did a good thorough inspection. And he, found some mechanical problems and was not going to be able to use his truck. So the supervisor called in somebody else who was not a good inspector of their equipment. And he said, here, just use my truck. You're just going out to do a demonstration. They showed how rope blocks worked and talked about how the electric grid works and things like that. How linemen wear rubber gloves so that they can work on the energized conductors. And so he did, it's late. he's got to be there for 9 o'clock, so he didn't get a chance to inspect the truck. He jumps in, goes out, booms up, and when he swings out over the top of the kids, this is what happens. The boom failed. When we did the investigation, what we found was the guy that operated the truck 2 days before this, he did not even operate the boom the day before. So 2 days before, he was working on an underground service, and it went from overhead to underground, and he had to try to pull the old wire out and pull new wire in. So on the jib of this truck, he actually hooked it up and was trying to pull the wire, totally overloading the boom, overloading the winch and everything. So he did everything wrong. And as you can see on the turntable, he actually broke some of the bolts from that turntable. They were actually able to get the wire done. He boomed down and drove the truck in, drove it the entire next day. Didn't get in the boom, and then this happened in the morning, and so the guy with his wife watching and almost 200 kids was killed from a boom failure. That's about the end of the presentation. So I have a lot more slides that I use when I get to do fire or first responder training. So as utility safety professionals, have we done enough to inform our local folks, our first responders, about the electric hazards? It's time to think about how we can share these hazards with our local first responders. Even some of the safety contractors that are on this web and watching this. You have folks, or folks who are first responders. Try to set up with them and let them know what some of the electric hazards are. We just need to get this message out to them. We don't want to lose another first responder or a customer that might be just trying to help a neighbor out after a tornado, flood, or something like that. So let's just keep in mind that we can do more than we have been doing. A lot of utilities have demonstration trailers. They go out and they show how electricity works and things like that. They'll go to schools and things. And the biggest message is don't touch down power lines. But I do understand, as a first responder, you are going to do what it takes, whatever that is, to try to get to a victim that needs your response. So we just need to make them aware, keep them safe. I just thank Brent and Bierer Meters and the electric culture of safety for allowing us to come out and do this. And thank you. Have a blessed day, and we'll see you next time.